This is my 6.3 numerical model. Introducing the numerical model. The numerical model has three different areas: linear motion, angular motion, and projectile. And I will be concentrating on linear motion. Um, so it's basically a mechanical analysis of human movement in sport, and we'll be focusing mainly on basketball. The numerical model is linked to physics using Newton's three laws of motion. So linear motion. Linear motion has five parts to it. It has distance, displacement, velocity, speed, and acceleration. Linear motion occurs in a straight line, and all five of these are part of the linear motion. So, linear motion with Newton's laws, there are three. There are inertia, acceleration, and action and reaction. And Newton discovered gravity when an apple fell on his head when he was sitting under a tree. But anyway, getting back to it. Newton's discovered gravity. He then came up with three rules about motion. The first form of motion is called inertia, and inertia is when an object is reluctant to move or change shape unless another force is put on it. For example, a basketball won't be moved without a player throwing it or bouncing it, because the force to move a basketball is the arms of the player, and when the player pushes and the ball goes forward, that is the force making the basketball move. However, the force being put onto the basketball must be bigger than the inertial value of the basketball, otherwise the basketball won't go anywhere. So a basketball is quite light, so it doesn't need a huge force. Whereas if you're in the gym and you try to move a big dumbbell, then it would take a bigger force of newtons to move the weight. The second law is called acceleration. This theory suggests that if you put a force down, you accelerate in the same way. For example, a basketball player jumps up, they will apply a force onto the ground and the force will be applied back. But this is a vector, so the size and direction plays a factor into what way you go. So if you apply a big force onto the ground but you're unbalanced, so let's say a player's trying to take the ball off you and you jump with the instep of your foot, you could jump high or jump well with height, but the direction might be a bit off because the angle that you put the force down, it will go opposite to that. So if you put a force down, it will go straight back up, whereas if you put a force 45-degree angle, you'll go to the 45-degree angle opposite. So this could force your jumps to be unbalanced and in the wrong direction, and therefore have an impact on your shooting. The size of the force is also taken into account, because the lighter player will, in theory, jump higher, but you could argue that the bigger player could have more of a muscle mass. So although they are bigger, they have more muscle, which means they could utilise more fibres and jump higher. And the third and final law is called action and reaction. This theory suggests that for every action it has a equal and opposite reaction. So for example, when you're shooting in basketball, you apply a force onto the ball and the ball puts the force back on you, and therefore the ball goes up and hopefully scores in the net. So this is the same with any other sport. So when you're kicking a football, you're kicking into the ball, and the ball gives the force back, which makes the ball travel. Just like tennis, you're serving, coming over the shoulder, hitting it hard, and the ball's giving the same force back, making the ball go. So centre of mass. Centre of mass is an imaginary point that is on our body, or it could be outside of our body, depending on what movement we're doing. So if we're standing in the anatomical position, the centre of mass will be around our belly button. And if you're like beginning to do a dive or start a swim race and you're bending over, the centre of mass will change to the outside of your body. So basically the centre of mass is the point in which your body is most balanced in all directions. So if the centre of mass is outside the body, then rotation is about to happen. So the swimmer is going to rotate because his legs are going to go up into the air and change on a 180 degrees or maybe a 90 degrees. Whereas if you're in the anatomical position, and let's say you just go jump up, then when you're jumping, the centre of mass will just go up or down the torso depending on what part of the jump you're on. So like if you apply a force underneath the basketball, that will make the basketball spin backwards, and that can benefit shooting. So this can happen in all types of ways. So the first arrow, which is here, is your centre of gravity. Then your feet on this particular one will be your base of support, and then the point from the base of the support to the centre of gravity is your line of gravity. So this is a numerical model, and we will be using this more to describe and translate in 6.4. We'll be comparing two participants, Charlie and Aaron, one being an experienced basketball player and one being a not so experienced basketball player, and just looking at different sort of newtons they put on and their weight and how that affects, and different angles and stuff. So when performing all the tests, you can film it and look at different sort of angles, but if you change the camera angle ever so slightly, it can change the angles, impacting on performance and the results themselves. So when filming it, it's important to set the camera up in the right direction and make sure it's on a tripod. And you can also put different features onto the camera, such as slow motion. So when being tested, it's better to wear limited clothing, because for our test we did a vertical jump and we had to measure a 45 degree and 90 degree angle in the knee. So if you're wearing baggy joggers, then it might be difficult to measure that angle precisely. Whereas if you're wearing like base layers or short shorts or something, that would be easier to measure and get more accurate results. There are three planes of motion. There are transverse, frontal, and sagittal. The frontal movement will be moving like taking away from the body, so when you're passing a ball in basketball, that'd be on the frontal plane when you pass the ball. And so the actual test itself, we did 3 different jumps. We did a counter movement jump, a 45-degree angle jump, and a 90-degree angle jump. Before taking part in the tests, the participants were given a PAR-Q to fill in and give consent. The participants did a 5-minute warm-up on the exercise bike to ensure that the muscles were warm, so the risk of pulling a muscle was less, and their muscles were ready to perform, so all the blood was in there and all the fibres have been activated. The participants went onto the force plate one at a time to measure their weight in newtons and convert it into kilograms, just so the force plate could measure this when they jump. The participants went into a squat position and other pupils measured a 45-degree angle or a 90-degree angle, depending on what jump it was, with a genometer. The participant put their hands on their hips so they didn't have any momentum for the 90-degree and 45-degree jump. The participant then jumped, and the force plate measured how many force in newtons the participant put onto the force plate. It also measured how high the participant went, so the second jump was a 90-degree angle and using the same principles, and the angle was measured by a genometer as well. However, the final jump was a counter movement jump, also known as CMJ. In this jump, the participants had freedom to do what they wanted, as long as they kept their legs straight in the jump, so they could use their arms for momentum, squat down as low as they wanted to bring themselves up to have momentum. Ideally, they would have started high and then dropped into a really low squat position, and then that would be the braking phase, and then activate all the muscle fibers in their legs to propel themselves up again, and using their arms to keep them in the air for a longer time or maybe push them higher up. That way they can generate maximal force. And that is my presentation.